Hello everyone, today we will talk about interface and object relations. As part of today class, we will discuss about interfaces. We will see why we use interface. We will also check about the implement keywords, and we will also understand the multiple inheritance, and we will also discuss about interfaces versus abstract classes, and then we will look out our different kind of object relations like association, segregation, composition, dependency, and summary. So as a part of interface is like a contract, right, where we don't have any method implementations. It provide us 100% abstractions, and it help us to achieve loose coupling between the systems. It acts as a bridge between abstractions implementation. It introduced Java 1.0 to support multiple inheritance of type. So here you can see how we are achieving loose coupling with interfaces, right? So let's say if you discuss about this particular order service. So in order service, you can see we have a method known as process order, and to process our order we have to make a payment, right? So as a part of, if there is no interface, then we have hard coupling, right? We have a tight coupling between order service and card payment. So there is only single option to process a order. You have to make a payment via credit card because there is no options. But at the other end, once you talk about the interface, then we are providing a loose coupling via payment interface. Now this payment interface have three implementer. One is like UPI payment, then other one is like credit card payment, and the last one is wallet payment. Now the user have choice to make a payment, correct? So based on their payment convenience, the user can opt for UPI payment, credit card payment, or wallet payment, and then user can make a payment and complete the order. So that's how we are able to provide the loose coupling with interfaces. Now there is a implement keyword is used to implement interface via class. So and it also help us to provide multiple inheritance in Java. In earlier classes we have discussed that multiple inheritance is not allowed in Java at class level, but interfaces, with the help of interface we can achieve multiple inheritance because there is 100% abstraction in the interface, right? So in 100% abstraction means there is no default implementation provided within the interface. So as part of 100% abstraction, we can create two interface, and both interface can implement via particular class. So in the given example, you can see we have a printable interface and we have a serializable interface, and both interfaces have their own purpose. Printable interface is used for printed a document, while serializable interface is used for serialize the data. And both interface can be implemented by report class, and whenever we required, we can call the functionality to print the report, or whenever we need, we can serialize the report. Okay, now let's move to code first, then we will discuss about the difference between interface and abstract classes. So as part of this class, I have prepared one demo. We have product as a abstract class where we have a product ID, name, price, and quantity. We have two methods where we have an implementation like update stock and calculate discount. So update stock, we will increase the existing quantity with the number of quantity we receive to update the stock. In the same way, we will calculate the discount, whatever the percentage we are applying for a particular product. And we have a abstract method as a calculate final price to calculate the final price of a particular product, because it depends on multiple factor like your state, on your transportations or your distance between the delivery, right? So all those things will calculate the price differently on different basis, right? In the same way, we have a installable and returnable interface, right? So installable interface like give us the facility to make a product installable, and returnable interfaces give us the facility to make a product eligible for return, right? So if you talk about the real world example, so we are purchasing lots of things online, e-commerce site like Amazon or Flipkarts. So some of the products are eligible for return policy, and some of the project are not eligible for return policy, right? So in the same way, we can categorize the behavior of that product. Means, is this product is eligible for return or not? In the same way, some of the product is also eligible for installation, and some of the product are straight away, so they that product doesn't require any installations. So in the same, if you talk about this, the some example like laptop, right? So if you talk about laptop as a product, so this laptop may eligible for return but not eligible for installations, right? Because we don't need any installation on laptop. But if you talk about some DIY product like sofa, double bed, you may have like AC, right? Like water purifier. All those things are eligible for installations as well, right? Even some of the product also eligible for installations as well as return policy, right? So if you talk about like AC, fridge, washing machine, or maybe your water purifier, all those product required installation as well as they also eligible for return policy. But once you talk about some product like study tables, or maybe a sofa set, or maybe some other thing where we may not require any written policy but installation is still required. So I think you can relate this particular thing where we need a abstract class and where we need uh, interface. Like, so abstract class is help us to drive the common attribute within the across within the system, or you can say across the software, right? So if I talk about the common attribute for a product, so common attribute for a product could be your product ID, name, price, quantity, while the installable and return label help me to drive my product policy. Means, do we need to provide a return, do we need to provide installation on a particular product? So that is like a real world example we can relate on. Now let me run this example. So we will create one application class, and this application class may have your main method. Okay, now sorry, now we can create a product object. So let's say create laptop, and this is your new laptop, and we just simply assign the values like laptop dot name we may have Mac Pro, price we may have maybe like 50,000 something. Okay, it is a double value, right? And in the same way we may have laptop dot product ID, let's say 101. Then we may have laptop dot quantity. Okay, so quantity may have one. Product ID is long. Okay, product ID is long. So in the same way we can provide product ID as a long here. Now if you run this, so laptop, then we can have price, so you can print out. So this is a returnable product but not installable product, right? So in that way we can have the calculate price. In the same way, we have discount. So whatever the discount we can provide, let's say 10% discount. Now, now this is eligible for return. Then we may have laptop dot return product. Okay, so this is also possibility. Now let's say we have another product like sofa. In the same way, we can assign sofa dot name big fit, or maybe you can say L shape sofa, L shape 5-seater, and then price we may have like 30,000, something like that. Product ID we may have 201, and then quantity can have 1. Now in the same way, we can calculate the price of sofa. What? Okay. Discount. Discount maybe 15%, something we can give here. Then this is the benefit of using interface, right? So now this sofa product is eligible for return policy as well as installations, right? So we have two interfaces. So you can see we have a return product as well. Okay, so we have schedule installation. So as of now, we didn't provide any return policy. We didn't make it eligible for return policy. Then as of now, we are just implementing the installable. So we don't have a return policy in this product. So let's run for this program first. Okay, now you can see the price of sofa is 50,000, and discount is 10%, and this is the discount we have to apply in the price. Then we can calculate the final price after discount. In the same way, we have a return policy available for this product. So this product is like is eligible for return. In the same way, we have a sofa price of 30,000, then we apply that discount, and this is the discount we have to provide to the price. Then we have the final price. And you can see this is the final installations scheduled, because it is this product is eligible for installation. Now we may later we may found that we can also provide the return policy in this sofa product. So we just need to add that returnable interface, right? So as soon as you implement that returnable interface, you just need to override that method, and you just need to write down. So here you can see this is also a part of your multiple inheritance, right? My sofa class is implementing more than one interfaces, right? So interface help us to provide a multiple inheritance, while a class only provide single level inheritance. So you don't have any opportunity to uh, add number of classes in this particular class, right? So only interface is providing the multiple inheritance, while class is only help us to extend the functionality in my child class. Okay, so here you can write it. So in the same way, now we have made this sofa eligible for return as well, right? So now you can say return sofa dot return product. Okay, so this is also eligible. So now you can see the sofa is also eligible for return. So I hope this is clear. What is the difference between interface and abstract class, and what are the use of these functionality in real world product. Okay, now move to our slide. What we have discussed till now, we have seen interface versus abstract class, and we have also seen the benefit of these things. So here you can see the purpose. The purpose is like define a contract or capability. So whatever the contract you have to define within your product, like if you have to provide the installation, then you can write as interface. If you provide the return policy, then you can write another interface. So and based on these interface, you can segregate the functionality, right? Whenever you require, you can list out those functionality on your product. In the same way, abstract class help us to write down the common behavior in the class, and that can be uh, come as a parent child relations, right? And you can also implement your own functionality if that is not coming as a common functionality, right? So in the methods, only abstract methods by default public and abstract. So interface is 100% abstraction. So all the methods are abstract there. You can't write any implementation on the interface. While in abstract class, you may have abstract method as well as your concrete method. Concrete method means you can provide your implementation in abstract class as well. Variable only public static final. So if you don't write anything, so by default all the variable are constant and treated as a public static final uh, variables. While if you talk about the inheritance have their own fields. So we have seen that inheritance in abstract class. So abstract class we have protected, right? So protected, why we have used protected, we have discussed this thing earlier class. Protected help us to give that variable access to my inheritance label, right? So all the child classes of this product class have the access of this product class variables. So that's why we have provided as a protected. Now constructor interface has no constructor, because we this is 100% abstraction. There is no object created separately for interfaces, so they don't have any constructor, while abstract class may have constructor. Uh, sorry. A class can implement multiple interfaces. We have seen, we have implemented we have implemented returnable as well as your installation policy with the separate interfaces, while class can extend only one abstract class. Keyword we are using implement for interfaces, extend for abstract class. Access modifier methods are implicitly public. So if you don't write anything implicitly, all the modify access methods are treated as a public. Methods can have any access modifier. So we have seen we in our abstract class that we have used protected access modifier, right? Use case, we already seen that when you need to define capabilities or roles, you can use interfaces, and when you want to share common code, then you can use abstract class. Multiple inheritance, yes, throughout interface you can provide multiple inheritance, but once you talk about abstract class, so you can't provide multiple inheritance through abstract class, because there is only single class you can extend. Okay, now move to Okay, now discuss about the object relationship. So basically we have four type of object relationship. One is like association, then aggregation, composition, and dependency. So association is like a relationship where two objects can exist independently. Once you talk about like example teacher and student. So teacher and students, both objects have their attribute and they can exist independently. Means teacher have their own attribute like their name, ID, their the course they are teaching, the university they are working, right? In the same way the student have their own ID, student have their own name, right? And one is teacher can associate to multiple student, or one student can associate with multiple teachers, right? So their in existence is uh, valid without any hard dependency to each other, right? So once you talk about the aggregation, so aggregation is like a department and employee. If you talk about, so it is basically has a relationship. Department always have the employee, right? So still there is a dependency, but that is not that much tight coupled. Why that is not that much tight coupled? So let's say if a employee joined as a technology domain and later on he has promoted to a product domain. So in that way, the department of that employee change from technology to product. So still there is a relationship, but they can change from each other, right? So earlier, let's say there is an employee associated with a department known as technology, and then later on the department has changed for that employee to product domain. And while we are talking about the composition, so this is like tight coupling. So the relationship between these two objects will never change, right? So if you talk about the house and room based on objects, so if there is a room exist inside the house, so you can't remove that room from that house, right? That is always there. So if there is a building or there is a hotel, and in that hotel there is a room 101, so that room you will never remove from that hotel, because that is always resides there, right? So that is a like a relationship which cannot revert or which cannot remove, right? So that is a composition. Once you talk about the dependency relationship, so dependency relationship always says that you can't complete a order without making a payment, right? So if you talk about a real time example like e-commerce domain, and you are purchasing uh, anything from the real e-commerce domain like Amazon, Flipkart, then you have to make a order. For completing that order, you have to opt for one of the payment methods, right? So like your cash on delivery, your credit card payment, your bank account payment, your UPI payment, right? So all those need to happen, otherwise you are not able to complete your order. So that is why we can say order service is always dependent on your payment service, correct? So I hope this is also clear. And why it is required, so it help us to write a clean code, right? And it also help us to decide based on the relation we can decide the dependency between the objects, okay? So in some kind of real world example, we already discussed as a, like e-commerce. If you talk about the order service, then we have multiple type of payments, so you can opt for that. And in the similar way, we have a notification service. In notification service, you can opt for SMS, email, and push notifications. Based on that, you can complete your notification. And in the banking domain, you there is a dependency between account service to transaction repository to databases. So every account service is always uh, write that transactions to databases to make that consistent. So that's it for today class. we have discussed about the interfaces. We have seen why we have used interface and what are the benefit of using interface versus abstract class. We have also seen the implementation of multiple inheritance via interfaces. We have also seen about the object relationships like your aggregation, association, composition, and dependencies. And we have also seen some kind of real world example, and we can relate these concept and how these concept help us to write a clean code. And that's it for the today class. In next module we will discuss about the object classes and some Java keywords. Thank